In a previous video, we spoke about the fact that for two triangles to be congruent, we have to have 6 pairs of things that are corresponding. So we have to have corresponding sides as well as corresponding angles. Now, we also spoke about the fact that in order to prove that two triangles are congruent, we don't actually need all 6 pairs to be proved. We only need to prove 3 things. So in a previous video, we showed a side proof. So if 3 sides are congruent, then the triangles are congruent. We proved one of those. We also looked at a side angle side proof. And now it's time for us to move on to an angle side proof. So what does an angle side congruence look like? Well, it looks like this. If we have a triangle here and we have 2 angles there and a side that is not included, and then we have another triangle and we have congruent corresponding angles, and again one side not included that is congruent to the other triangle. So these 2 triangles are congruent. That information is enough to show that it's congruent. So now with that knowledge, let's go ahead and do an example of an angle side congruence proof. Okay, so now we're ready for our 2-column proof to prove that triangle ACD. So ACD, which I'm tracing out here, is congruent to ECB. So ECB is what I'm tracing out here. So it's a little weird because we have, parts that are superimposed on other parts of our triangles, but I'm sure we'll be able to get this. All right, so we're going to start with our table, and our table will have to have statements. And of course, we will have to support our statements with reasons. Okay, so the first thing we always start off with in our column or 2-column proof is our given statements. So our first statement is that angle DAC is congruent to angle BEC. And since it's not marked on our diagram, let's go ahead and mark it. So angle DAC, which is this guy right here, is congruent to angle BEC, which is this guy here. So those 2 are equal in measure. They're congruent. All right, and the reason we know this is because it is given. And we always, again, start with the given stuff. There's something else that's given, so let's get that down. We know that side DC is congruent to side BC. So let's get that in our diagram as well. Side DC. So just because there's a little bit of ambiguity here as what the side is, if I put the hash mark in, I'm just going to trace it over for your convenience. So side DC is congruent to side BC. So I'm tracing that so we can see it better. We don't have to, that's not a necessary step, but just so you can see that our 2 congruent sides here is just what I traced, not the whole line segment. Okay, so now that's what we're given, and now we have to keep going. So we have pairs of congruent angles and we have pairs of congruent sides, but we need a third thing. Now you may recall the reflexive property of congruence. Since both of the triangles share that angle, then that angle is equal to, well, that angle. So our second statement is that angle C is congruent to angle C, which, well, isn't that obvious? Not really. You really have to back up everything you say. So that's because of the reflexive property of congruence. So we'll just say the reflexive property here. All right, so how does that help us? Well, we are trying to prove that triangle, and I'll trace it again, ACD, so ACD is congruent to ECB, so we want to prove that it's congruent to ECB. And I have an argument here that we actually know enough to say that they are congruent now. In order to prove congruence, it is sufficient, one of our methods is to say that the angle, and the non-included side, so the side outside of those angles, are congruent. So if the angle, and side are congruent, then the triangles are congruent. And here we have, in our triangle ACD, angle, and the side outside. How about the other triangle though? Triangle ECB. So in triangle ECB, we have angle, and the side outside. So we've gotten to where we need to get to. And that is the fact that triangle, so this is our third thing here, triangle ACD is in fact congruent to triangle ECB, and that is because of the whole angle side theorem. And we're done.